Assalamualaikum warahmatullahi wabarakatuh. Good morning, hello everyone. My name is Dinda Alfiyyah Nur Azizah. You can call me Dinda. Here we will learn math together with the material of arithmetic sequences and series. Let's focus and prepare the stationery. Without any further ado, let's start learning together. Hi, can I ask you about arithmetic sequences and series? It's okay, let me explain. So, we've already talked a bit about sequences, but now we're going to actually put some more specific terminology to them and look at them in a more general sense. So, in this video, let's learn more about arithmetic sequences. An arithmetic sequence is a sequence that has a constant difference between terms. So, the formula is structured in a way that would look linear in nature. So, in arithmetic sequence, we'll start with the number. Let's revert to this number as A for now. In that case, since there is a set amount of difference that is always being added on, whether that number is negative or positive, we can revert to the difference as the common difference and we'll denote it as D. This means that our second term will clearly be A plus D. Now from here our third term will be A plus D plus D. Holding it? And our fourth would just be an addition of D. One more time, giving us A plus D plus D plus D. And notice that we can actually simplify this. This here can be simplified to A plus 2D. And this can be simplified down to A plus 3D. But if we look at this number here, it seems to always be trailing behind by 1. From what term number we're on? This is easy to account for, however, since we can just write a formula like this. Notice that if we are to look for term 5, then we get T of 5 is equal to A plus 5 minus 1D, which becomes 4D. Awesome! Let's go right into looking at an example of our first sequences. So here we've got 3, 5, 7, 9, and 11. Now a sequences is just a collection or list of numbers. A series, on the other hand, is the addition of a list. So, while this is an example of an arithmetic sequence, an arithmetic series would look like this, which is the addition of all the numbers. Now, instead of denoting this as T of n, which is represent the number of the term we're looking for that we're on, we will denote a series with this as of n, which we will use to represent the sum of all the numbers up to the nth term. Alright, so first of all, let's start by focusing on arithmetic sequences first and bring up the formula for it again. So, the A here stands for the fourth term in the sequence, and the D stands for the common difference. And if you remember, this formula is essentially a summarized version of this, which describes each term as the first term plus the multiplication of the difference between the terms, depending on which terms we're on. So, as you can see, each of these equations represents each one of these terms in the sequence. Good! And even arithmetic series is represented as the addition of these terms. Then we can technically write it out as the addition of these equations, like so, since they are representative of each term. So, what are the uses of sequence and series in everyday life? Alright, let's see the application. There was an uncle named Ali who loved farming. One day, he started planting trees and took good care of them. Every day, Uncle always watered and fertilized his plants. So, every week, Uncle always observed the height of the development of his plants. In the first week, the plant grew and had a height of 3 centimeters. For the second week, the plant increased in height to 8 centimeters. Because it grows well, in the third week, the plant grows to 13 centimeters tall. Uncle plans to harvest the plant in the 12th week. So, what do you think will be the height of the plant in week 12? Well, try to notice the increase in plant height from the first week to the second week is 5 centimeters. Well, as from the second week to the third week, it is also the same 5 centimeters. Well, as for the increase in the following weeks, we assume the same increase, which is 5 centimeters. So every week the plant has a fixed height growth of 5 centimeters. Well, here there is an arithmetic sequence. From the problem of the growth of the uncle's plane, we can change it into the form of series of arithmetic numbers such as 3, 8, 13, 18, and so on, with the right difference of 5. Now, in the problem of uncle's plane growth, we can work on it using this formula. Take a look again. The first term, or A, is 3 centimeters. The second term is 8 centimeters. The third term is 13 centimeters, with the difference between the terms is 5 centimeters. So the 12th term is T12 equal 3 plus open bracket 12 minus 1 close bracket times 5. Obtained T12 equal 2 plus open bracket 11 close bracket times 5. Obtained T12 equal 3 plus 55 equal 58. So, it can be concluded that the height of the uncle plane in week 12 is 58 centimeters. Well, now you understand, right, what is arithmetic sequence and series? I did. Thank you. Okay, until this point our discussion. Thank you for watching. I hope what I say earlier can be useful for friends. Please apologize if there is something wrong with my words. Please forgive. Bye-bye friends. Wassalamualaikum warahmatullahi wabarakatuh.